Okay, so today we're going to be talking about exponential growth and decay. So growth meaning it's getting larger each time, and then decay would mean that your final output is getting smaller each time by a factor. So we're just going to kind of go through and jump in and see what we get. Okay, so the number of people attending an event double each year. So in event year one, we start off with 20, and then year two, we start off with 40. And so year three, we're going to double that again, and we get 80. And then year four, we double that again, we get 160. And then year five, we double that again, and we get 320. Okay, so to get our points over here, we're going to go 80, 160, and then 320. And so let's start graphing these. We haven't done much graphing with exponential functions yet. So let's get them on a graph and kind of see how is that going to be different from what you've been graphing in the past. So we have 0.120, so that's here, 0.120. And then we have 0.240. Okay, so far it's straight, okay. 0.380, 0.380, and now, it's not straight anymore, it's starting to curve. And we have 160. Oh, we're all the way up at 160. And then 320. Okay, so we're all the way at the top here. Okay, so you can see that we're no longer dealing with a straight line as we've been in past chapters. We're starting to get into this curved line, which indicates that it's an exponential function as well. So we can see that the numbers are getting bigger, so this is what we call exponential growth. Okay, so we've got exponential growth. So let's talk about our formula. So I've asked you for all of this information down here, okay? So I want to make sure that we have our function, get our function formula down. And so we have g of n, and then we're going to multiply it by some type of, we've got two things that have got to get multiplied together, right? You can either write it with the function with the n minus 1 included in it, or you can figure out how to, you can use the non-n minus 1 looking at the previous function. I don't really care which one you use, as long as you use it correctly. So a lot of times people get confused at like, okay, so how do I get my two parts of this function? I know I've got to have an exponent here, so and what do I start multiplying with? Well, I take it back to event 0, even though there's no event 0, there's only the first event. But if we go, let's say there was an event 0, how many people would be at that event? So going forward, we're multiplying by 2 each time, right? Well, if we divide by 2, we end up with 10 up there at event 0. And so that is going to be our multiplier, okay? So it's 10. And then each time we're multiplying by 2, so that's our factor of 2. So each time is 2, right? We're multiplying by 2, so 2 to the nth. Okay, so depending on what event number it is, that's going to be how many times we multiply this squared by. Okay, so the y-intercept, there is no y-intercept. We don't give you 0.0. We just use the if the hypothetical if there was a 0.0 up there as your but there is no y-intercept. There's no event 0. Okay. We don't celebrate your 0th birthday party. Okay, and so now we have a and b, and these are kind of new things that I'm introducing to you right now. Well, the formula is actually written like this. We have g of n equals a times b to the n, okay? So when you have this formula written, we're talking about a, okay, that's that a right there. And then we also have b, okay? So if 10 is a, then b has to be 2. So we have 10 and 2. Okay, so the domain. This should look a little bit familiar, okay? The domain are the x values, and the y's are the range, okay? Or the g of n's. We call them g of n's in this case because we're using function notation. Okay, so we have our x value, our domain is our x values, and this one's pretty simple. Both of these are pretty straightforward. It's just 1, 2, 3, 4, 5. Okay. And then our range in this case is all the y values or the g of n values, and it's 20, 40, 80, 160, 320. Okay, and that's it. Okay, so let's start on the next one. All right, so this one I'm giving you the domains to substitute in. So let's talk about, you have your negative exponent. Maybe you're not understanding that negative exponent. Maybe you don't get, like, how do you do that negative exponent? How do I get my number in there? Okay, so, well, what you do is, if you're not sure what to do with that negative exponent, is start looking for the pattern in what you have here. So we have 3 times 1/2, and we're going to replace the x value with a 0. Okay, well, anything to the 0 power is 1. So 3 times 1 is 3. Okay, so then you have 3 times 1/2 to the first power. Okay, well, 3 times 1/2 is 1 1/2, or 1.5, and you should be using your calculator. I know this one I'm doing in my head, but you can use this in your calculator to get these answers. Okay, so the next one, you got 3 times 1/2 to the second power, and you're going to substitute that into your calculator, and you're going to come out with 0.75. Okay, so give me 1 sec. Okay, sorry about that. I'm gonna grab my calculator. Okay, so we've got 3 1/2 to the second power, and then we've got 3 times 1/2 to the third power. So again, just a reminder on your calculator, I do want to practice this with you guys. So we're going to go 3 times, and then we can say 1/2. Actually, let's put a parentheses in there. So 1 divided by 2. Okay, and we're going to do that to the third power in this case. So we get 0.375. And remember, if you write this in your calculator the right way, you get kind of a cool, like, formula you can just go back up to and substitute your next number in and change that to 4. Okay, and hit enter, and you get 0.1875. Okay, and so let's go back up to this -1 now. All right, so if 1/2, you can see that it's getting half, it's halving each time, right? So I want you to predict real quick, what do you think is going to go here? So if it's dividing by 2 going this way, then it's multiplying by 2 going this way. So we should get 6 there. So we can go back up to our formula up here, and we can actually change this to a negative. So put that negative there, and -1, and we get 6. Okay, so we already know our formula for this, our y-intercept, and we've got all of this information in here. Okay, so we have our formula. Our formula is 3 1/2, and so if we look back up here at when we were looking for A and B, our starting point is A, and then the multiplier is 1/2, so B is 1/2, and our range, don't forget those curly brackets there, 6, 3, 1.5, 0.75, 0.375, and then 0.1875. So our range is all your y values, right? Okay, sometimes I'm going to ask you for the range, sometimes I'll ask you for the domain. Most of the time I ask you for A and B, and you just got to know that the first one is A, second one's B. Okay? All right, so let's put these on a graph. So we've got -1, +6, 0, 3, and you can see it's getting half. We're halving it each time. And then we have 1, 1.5, 2, 0.75, so it's somewhere in here. And then we're gonna half that. So 3, and then we've got somewhere around here, and then 0.1875 for 4. So you can see that this one's actually getting smaller, right? So this one is called exponential decay. Okay. Okay, so that's our kind of rundown on these basic two problems here. So our first one, just to review, we had to figure out 10 by going back one to get our 0 to get 10 here, right? Our 0 point. And then we know that our multiplier is 2 because it's being multiplied by 2 each time. Okay, we said y-intercept was no event 0, so there is no y-intercept in this case. And then we have our a is 10, our b is 2, and our domain values are just the x values, our range values, the y values, and you're just going to graph them, right? Our second one, we have our a and b. So we've described a and b. Oh, I almost forgot our y-intercept. We'll come back and do that in a second. We see that the graph is getting smaller and closer to the x-axis. We call that exponential decay. And then we have our a values are 3 1/2, and our range is just whatever our outputs are, okay? And then our y-intercept, it is our, wherever x is 0 is our y-intercept, so our y-intercept is actually 0, 3. So this is our y-intercept. Glad I reviewed that real quick. I almost missed that. Okay, so make sure you got a calculator for this section. Good luck on it, and I'll see you in class.